Alright, this is going to be talking about Punnett squares. We're going to take the information that we learned yesterday about alleles and traits and heterozygous, homozygous, and we're going to now solve problems with them using a Punnett square. So a Punnett square is basically a grid system for predicting the genotypes that result from the mating of two organisms. So if you had, let's say you had a parent that was heterozygous here and a parent that was heterozygous here, and you were to mate those. So these are two different organisms and you're mating them. You're going to end up with 4 possibilities of genotypes. And remember, genotypes are going to be what is in the gene. Okay, so remember that genotypes, again, the genotypes are going to be what's in the gene, and the phenotype is going to be what's in the, is what you're going to see. Alright, and the reason why we want to do Punnett squares here is because they allow us to find the probability of getting a particular genotype or a particular phenotype. So we can look at the Punnett square, see the possible outcomes, and use this to predict what the possibility of getting a homozygous dominant or a heterozygous individual. Now we have 2 types of crosses. We have our Punnett squares. The more basic one is a monohybrid. That was like the one we just saw on the previous slide. This in monohybrid, you're looking at a single trait. So this could be color of the leaf, the height, like whether it's tall or short. It can be a bunch of different things. Dihybrid is where you're going to look at 2 traits, and that could be color and height. So it's going to be more than just one thing at a time, and you're going to look at how do they combine together. Now, when we're talking about probability, to guess the possibility of something, you're going to take the number of different ways that event you want can be over the total. Okay, now for a monohybrid cross, you will always have the possibility of out of 4. So everything for monohybrid is always going to be out of 4. For dihybrid, because we're looking at 2 traits, everything's going to be out of 16. So 3 out of 16, 4 out of 16, and so on. A lot of times with the monohybrids, you will see the 1/4, 2/4, 3/4, things like that. So for monohybrid, you're always going to have a possibility out of 4. For dihybrid, it's going to be out of 16. Now, how do we actually go about solving and setting up a Punnett square? So the first thing is you're going to have word problems. In the word problems, they're going to give you information. The first thing you want to do is you want to underline the phenotype. So a lot of times the description of what the parents look like or what the parents have are going to be given. Based on which allele is dominant and which one's recessive, you can figure out the genotype of the parent. So let's say that they are heterozygous for tall. Okay, and we use the fact that T is tall, big T is tall, and little t is short. So if it's heterozygous for tall, that means that parent would be a big T, little t. So remember, heterozygous means it's one of each, and it's tall, so it has to have one of the dominant alleles. You're going to draw a box. So if it's a monohybrid, you would draw a 2x2 box, which will be a grid. So it has 4 boxes in it. And you're going to put one parent on the left, one parent on the top. Okay, it doesn't matter who goes where, just as long as you're consistent. Then you're going to match up. So you're going to do the one that's in the first row with the one in the first column, and then those would match up, and so on. And you'll fill out the entire chart for the genotypes. So this will give you the genotypes. Once you do that, you're going to then look at the genotypes and write what the phenotypes are. Okay, so you should be able to tell based on which allele is dominant what the phenotype will be. And then finally, a lot of times they'll ask for the ratio or the percentages of the genotypes and or the phenotypes. More often for the phenotypes, they're going to be looking for you to look at the genotypes and tell what those genotypes mean. So for a monohybrid, remember I mentioned it's 1/4 for every box, which is 25%. Now for dihybrid, it's going to be 1/16 because you have 16 boxes for each box, or a little over 6%, so 6.25%. So you can use these to figure out how many what the percentage is based on how many boxes have that trait or that phenotype. So let's say this one, and this one all had the phenotype you're looking for. So this is monohybrid, so each box is 1/4, so that would be 3/4 or 75%. Okay, so let's look at a couple of examples. So the first question, what are the genotypes, phenotypes, and accompanying probability if both mom and dad have freckles whose genotypes are heterogeneous, where freckles, which is big F, are dominant to no freckles, which is little f? So first thing you got to do is we want to go through and underline the phenotype. Okay, so we know that they have freckles, and it tells us that it's heterozygous. So that means that mom, let me try to write that a little better. Okay, so that means mom will be big F, little f, because she's heterozygous and she has freckles, and dad will also be big F, little f. Okay, so we put one of them on top here, we put one on the side, on the left side here, and now what we're going to do is we're going to go through and match up the squares. So this has a big F, so we put big F. This one has a big F, so we put a big F. So then that's big F, big F. This one is big F, little f, because this one is a little f. Again, big F, little f, and then two little f's. Okay, so now we can look at the genotypes. So, said mom has freckles, dad has freckles. Okay, well then that means mom has to have big F, little f, dad has to be big F, little f for the genotypes. Alright, now if we look at this, if it's big F, that means this has to be freckles. Big F, little f is freckles because it has at least one of the dominant alleles. Big F, little f, again, is freckles, and little f is no freckles. Okay, so that means we have 3 boxes that are freckles, so that means we have 75% freckles, but we only have 1 box that is not freckles, which is 25%. Now remember, these percentages should add up to 100 because they are percentages. So we could say 3/4 or 75%, and we can say 1/4 or 25%. Alright, let's do one more example. So brown hair is dominant to red hair. So if Harry marries Jenny, who has red hair, what are the possible genotypes of their children's hair, assuming Harry is heterozygous? Alright, so here we go. We're going to say that Harry is heterozygous for brown hair. So that means he's going to be big R, little r, whereas Jenny has red hair, so she has 2 little r's. Okay, so we're going to put Harry on top here. So big R, little r. Jenny has 2 little r's. Okay, now what we're going to do is we're going to go through and we're going to pair them up. So big R, little r, big R, little r, big R, little r, little r. Okay, that second one there should be little r. I made a mistake there. So this should be little r. So let me change that real quick without marking all over the screen. Okay, so little r. Okay, so, and if you notice, I'm writing the big letter first because that's kind of typically how it's done. All right, so we've done our Punnett square. We wrote our parents on either side. We matched up the letters in each box. So now let's go through and look at them. Okay, so we have a big R and a little r. That's going to be brown. All right, again, big R, little r is brown. Two little r's, that's red. And again, two little r's is red. So that means half of the boxes are going, 2 out of 4, half, is going to be big R, little r. So we say that 50% is going to be brown, and 50% will be red. Because half of them are brown, half of them are red. So this would be a monohybrid cross because it deals with just one trait. Now let's get a little bit more complicated. All right, so if we have a dihybrid cross, so in this case, we have if yellow peas are dominant to green peas, so that means that you have a big Y and a little y, and round peas are dominant over wrinkled peas. Again, big R over little r. What are the possible genotypes and phenotypes in a genetic cross of two heterozygous yellow round peas? All right, so here's where it gets a little more complicated. So now for parent 1, it's yellow and round. So is parent 2. Okay, so both of them are heterozygous, so that means that both of them are going to be big Y, big R, little r. Now, instead of doing just a simple 2 by 2 square, we are now going to do a 4 by 4 square. Okay, now how this works is you are going to take your 4 letters for each parent and you're going to combine them into 4 different combinations. Okay, so you're going to have all your combinations for parent 1 over here, and then you're going to have all your combinations for parent 2 here. Okay, and the reason why you do this, these are from the parents, and so you have to remember, when you go through meiosis, you're going to get one of each trait. So we've got to go through and we got to figure out what the possible combinations are. All right, and so how we do this is through a very simple process. You're going to take the first letter and combine it with the third and then the fourth. So in our case, remember, each parent was big Y, big R, little y. So we're going to take the big Y here, and we're going to combine it with this one, then we're going to combine it with that one. So we're going to have big R, big Y, big Y, big R, and then big Y, little r. Then we're going to do the same thing with the little y. We do it with the big R and then with the little r. So you take the second letter, which is little y, big R, little y, little r. So you take the first letter, combine it with the third and fourth, then you take the second letter and combine it with the third and fourth. And so you should end up with 4 different combinations. And you're going to do it for both parents. In this case, because our parents are the same, our combinations are going to be the same. All right, so then we go through and we put those combinations on the top and then on the side. Okay, so now what we do is we go through and we match up the 2 letters, the 2 Y's go together, the 2 R's go together. So in this case, you have a big Y, little big R, okay? And we do that all the way through here, combining the 2 Y's together and the 2 R's. Again, remember the bigger letter, the dominant letter will go first. Now, once we've filled in our chart, which we're going to do one here in a minute, where I'll go through and fill it out. Once we fill out the chart, now we got to go back and do our phenotypes. Okay, now remember, big Y is yellow, little y is green, big R is round, little r is wrinkled. Okay, so if we have big of everything, that means it's going to be yellow, round. Okay, Again, this case is going to be yellow and round because it's going to be big for each of them. This one here will be yellow and round, and this one will be yellow and round. Because again, as long as you have one dominant letter, one big letter, it's going to have the dominant trait. This one will be yellow and round. This one here has two little letters, so this will be yellow and wrinkled. Okay, this one here will be yellow and round. Again, yellowed and wrinkled this time because again it has the two little letters. Yellow and round because we have big ones in each one. Yellow and round. This time this one is going to be green. Excuse me. If I can spell green. Okay. Green and round. Okay. Again, green and round. This one we go back to yellow and round. Yellow and wrinkled because we have the little ones this time. This time it is green and round. And the last one has all little, so it's going to be green wrinkled. Alright, so now that we've gone through and figured out the phenotypes, we can count them up. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 yellow and wrinkled. And because our total is at a 16, so we say 9/16, we have 1, 2, 3 that are green and round. We have 1, 2, 3 that are yellow and wrinkled, and then we have our last one here in the very bottom that is green and wrinkled. So that's 1 out of 16. Again, you have 16 options here, so when you count them up, it's going to be out of 16. You're going to see less percentages with dihybrids because it's a little more tricky. It doesn't work out so evenly, so you're more likely to see something like 9/16, 3/16, something of that nature. Alright, so let's do one together. So Harry Potter is magical and has brown hair, while his wife Ginny Potter is magical and has red hair. So non-magical and brown hair is dominant over magical and red hair. So we've got to do Harry's genotype and Ginny's genotype. Then we got to figure out our combinations. Alright, so if Harry is brown hair, okay, we can either go with the fact that he's heterozygous or homozygous. In this case, I'm just going to assume he's heterozygous. Alright, so that would not be R. Yeah, that would be R. Okay, so that means he's going to be big R, little r. Ginny has red hair, though, so she's going to be 2 little r's. Now, they're both magical, so that means they're both going to have little m's. Now, here's where we have to do the combinations. With the combinations, you're going to take the first letter and go to the third and then to the fourth. So for Harry, it's going to be big R, little m, big R, little m. And then we're going to do the same thing with the second letter. So now we have little r, little m, little r, little m. Okay, Ginny has the same for all of them basically. So what we do for the first and third, first and fourth is going to be the same for the second and third, second and fourth. So all of hers are going to be little r, little m. Because she has the same letters that are repeating. Alright. So now that we've got those combinations, now we're going to go through and we're going to write them in. Okay, so we're going to put Ginny here on the left. So we're going to give her little r, little m. Harry had big R, little m, big R, little m. Then he had little r, little m, little r, little m. Alright, so now we're going to go through and pair up the r's. So big R, little r, and then 2 little m's. And if you notice here, because the combinations are the same for all of Ginny's, we can just write the same thing for this entire column. Okay, now the second column should be the same thing because it's going to be the same as the first column because you had big R, little m. Okay, so now for this column we're going to have 2 little r's, 2 little m's. Again, every row is the same because the combinations are the same. So we are just going to basically write the same thing down each column. Okay, again, the fourth column is the same as the third because the combinations are the same. And this is pretty common if you have something like this. Alright, so now what we can do is we can go through and we can look at what we have. Okay, so the big R, little r, that's going to mean, let me get a different color here, that's going to mean they're going to have brown hair. Okay, that also means they're going to be magical because the little m is a magical. Well, that's the same case for basically all of these guys here. Okay, so all of these first 8. So we'll come back to the numbers in a second. But all of these are going to be brown and magical because they're all the same thing. Now if I do a different color, let's say green over here, well if it's little r, that's going to be red and magical. Alright, so and again in this case, because the types are the same, or all of the letters are the same, that means that those 8 boxes are going to be the same. So what comes out to be the answer? The answer to the question, because they want the genotypes, is you're going to have 8 out of 16 are going to be brown magical, and 8 out of 16 are going to be not green. They're going to be red and magical. So in this case, we can easily do the percentages because 8 out of 16 is a half, so, and that's 50%. So half of the children will be red and magical, and half will have brown hair and be magical. All right, so this is an example. These are examples of how to take those traits and those heterozygous, homozygous alleles and predict what the children will be given the parents' information. We're going to focus on now just doing monohybrid. You have a practice sheet which will be due on Monday, so you have the rest of the period to work on that. I will be back in class on Monday or possibly at the end of this period to answer any questions, and I will go back over these examples with you. But please make sure you filled in the entire note sheet and that you start working on the practice problems.